Good morning, friends. I hope you all are doing well. Sorry for coming very late, making a video very late, but I got stuck in some work. So let's start. So my next video is on neural networks. This is a very important topic in many of the fields, like in machine learning, we do in deep learning, we do in natural language processing, we do in information retrieval, and almost everything we are doing in this whole world, almost every task we are completing with the neural networks. So, what is neural networks basically? Neural networks are whatever you see in your real life, whatever you see in your real life, whether it is a language, whether it is a human, whether it's a video, everything is a mathematical function of everything in this world is a mathematical function of uh, there's a mapping between input and output. So let's say I have X as a input and Y is my output. So what machine learning algorithms gives me a function, a mapping between the two data points like X and Y. And X we say is the independent variable. Independent variables are like I want to predict diabetes. So if I want to predict diabetes, diabetes is dependent on BMI. It's highly dependent on BMI. So diabetes will become my dependent variable. What I have is this is my dependent variable. So what my dependent variable is? Dependent variable is the thing what I want to predict. So like I want to predict diabetes. So diabetes becomes a dependent variable and it is dependent on what? It is dependent on BMI. I want to using BMI, I want to predict diabetes. So I want to find a relationship. I want to find out, approximate a function that gives me a relationship between BMI and diabetes. So how my diabetes is varying uh, if I vary the value of BMI. So if I find the relationship between these two, then I would say I can predict for any value of BMI. If any value for BMI comes to me, I can say whether the person is diabetic or not, or likely to be diabetic or not. So, in case of machine learning, neural network is a part of machine learning basically. So, in case of machine learning, my output is whatever we are doing previous in traditional algorithms, my output was I want to solve some problem. So for solving that problem, we'll be writing certain codes. We are writing certain steps and it is giving me the solution of problem. Nowadays, in machine learning, we are not finding out the solution of the problem. We are providing the inputs and outputs. In the supervised case, if we take this is a case of supervised. So in case of supervised learning, we used to provide input and output both, X and Y both. I know the person is diabetic or not, and I have the value of BMI as well. So I'll give both. What is the output of my algorithm is the output of my algorithm is a function, is a mapping between. So these two are my input. This is my input, and this is also my input. Okay. This is also my input, and I'm having output is a function. So that is why I'm saying neural network is a function approximator. Everything in the world, whatever we are seeing, whatever we are doing, whatever the things possible in this world, they can be represented in terms of a mathematical function. And how to define this mathematical mapping? How to define this mathematical mapping? Neural network is an awesome tool that can give you the approximation of your function. So let's take some example like I have this data you want to guess a function for this data. So it's very easy to guess. If you see the data it is 2, 4, 3, 6. So every data, every x is the twice of every y is a twice of x. So I can say this y is a twice of x. So if I say y is a twice of x, then I can say y is equal to, the relationship is y is equal to 2 of fx. So y is the 2 of fx. Then I have another data set in which I have x as 2, y as 7, x as 3, y as 12. So the relationship in this one, if I want to find out relationship, it's not that easy like directly we are saying it is y is the twice of x. In this case, it is not twice of x, it is not thrice of x, it is not even squares. So you need to think a bit to find the relationship. That is, it is the relationship that is y is equal to x square plus c. And well, I'm using c as the 3. So if I'm doing x square plus c, so for this, I need to think a bit if I'm doing manually. If I'm doing with a machine, then like SVM can, I need to go for some non-linear prediction method. So that the methods which is giving me the nonlinear kernels, they are successfully able to define this relationship. Like we can use SVM to find the relationship between these two data. Then further, now if I'm having this kind of parabola kind of curve. So if I'm having a parabola kind of curve and I want a relationship between x and y. So the relationship between x and y is not easy to guess manually. Uh, though if you know the function of parabola, because it's a standard parabola curve, so if you know this equation of parabola, you can easily guess it. Now coming to the next data. Now see for the next data, like if this is your data, then how do you define the functions? It's not possible to do it manually. Now this is where we required machine learning or the neural network. Machine learning is even not capable of like we if we are having a non-linear relationship, even though machine learning is working, SVM is having a powerful kernels available in that. But generally, the machine learning algorithm fails for a complex kind of data, like we are having images. This is one image, this is one image. So if I want to have a relationship between the pixels, image consists of different pixels. So if I want a relationship between the pixels and the output, like I want to identify river in this. So if I want to, so whether it's an image of river or not, that's my outcome variable. So I want a relationship between river and this image. So it's not easy to get the function for this image or for this image or even for this kind of data. There's some exponential or the logarithmic function possible in the first data. So such kind of relationship is not easy to guess. So for this, we require to go for neural network. For such kind of data, we need neural network. So let's see what is neural network actually. So neural networks are the structures that is having multiple layers. So you can see there are multiple layers available in this particular model, and there are first layer of neural network. We used to say this is a input layer. The first layer of neural network, we say it's an input layer, and the last layer of my neural network, we say it's a output layer. And rest everything in between the input and output, we are saying it is a hidden layers. So first thing, it is a layered architecture. Deep neural network is nothing but it's a layered architecture. I'll tell you what is the benefit of layers. So this is basically it's a layered architecture, and um, In this, we are having one input and one output. Input and output is fixed. We are having one only. And there are several hidden layers in between them. And at every layer, we are having several units. They are working parallelly. You can see there are, and every unit is connected to every other unit. So what we say, this units basically, the units available at different layer, these are called my neurons. This we say is a neurons. So there are several neurons at every layer and they are connected with the neurons at next layer. And if you say every neuron and at the previous layer is connected with every neuron at the next layer. So this architecture we say it's a fully connected. There is all neurons connected with every other neuron at next layer. So this architecture we say it's a fully connected network. Okay. So now let's know what is neuron actually. What we do in this neurons. So it's a parallel layered architecture and where every neuron is connected to every other neuron. So there is fully connected network. So what is the benefit of keeping this layers at first layer at very early layers? We used to get the basic detail, the abstract details of my image, like whether there is a horizontal line, whether there is a diagonal, or whether it's a smooth area, like whether there is some object present in the image. So I'm just finding the basic details. So this image is representing the horizontal lines. Okay. It is representing the horizontal lines or vertical lines or the diagonals or diagonals. So or we may have a smooth area. There may be a smooth area present in this. So if you see the output of the next layer, the middle layer. So if we go with the output of middle layer, at this level, we are able to find different contours. So in our face, we are having different type of curves available. For eyes, we have different curve. For nose, we have different curve. For lips, for design of lips, we are having different curves. So all the curves we are finding at the middle layers. And at the final layer, we are able to find the structure of the image, like the shapes of different faces. So at the final layer, we are able to get the shapes of different faces. So this is what is the purpose of using multiple layers in the deep neural network. So now coming to the neuron, what is neuron actually? So neurons are basically why we are connecting different neurons in the neural network. So basically neural networks are the simulation of human brain. In human brain, there are huge number of neurons. That is, you can say it's around 10 billion of neurons. They are working parallelly. So if you see this structure, this brain structure, there it is a brain of human. There are many neurons. They are massively parallelly connected. So we are having 10 raised to the power around, not exactly. I'm not saying this is the exact number of neurons. We are having around 10 billion neurons available in our human brain and several of they are connected through several thousands of connections. 100 of operations will be performed per second and the neurons also die off. So but it is a massive parallel architecture. So if we see the structure of one particular neuron, this is the structure of one particular neuron. Inside one particular neuron, there is a cell. There is a cell that is called nucleus of my neuron, and there are several dendrites. So these dendrites are connected through axon. Axon is nothing but is a channel that carries my signal. So how the human body gets the input? As a human body, we are getting the input through the sensory organs. So the five sensory organs we are having is we are using sensory organs to get the input from the environment. So we are having eyes, we are having ears, the five sensory organs we are having skin, then we are having nose, and last we are having is the tongue. From tongue, you taste something. So through these five sensory organs, we are getting the inputs. So these inputs through these dendrites, all these synapses are connected at the sensory organs, at different sensory organs. From this synapses, we are getting the signals, and through these axons, these signals carries to the brain cell, that is my neuron cell. And this at this particular cell, this these these inputs, what we collect from the environment, this get combined with electric pulses. There are certain electric pulses generated here, and it is combined with the electric pulses. And once this is combined with electric pulses, there is an output formed, and that output will be propagated through this axon again to the sensory organs or different organs, so that we can do certain actions. My output is the output of human body is actions or the emotions. We can do either actions or emotions. Emotions or feeling we used to generate through the facial expressions. So these are my output, are the instructions that is given by the human brain. So what is my electric pulses? What is my input and what's my output? So as I said, there are independent and dependent variable in the machine learning. So we are having certain independent and certain dependent variable. So inputs are nothing but is my independent variable. These are my independent variables, and this is my dependent variable. Dependent variable is nothing but is the thing I want to predict, and independent variable is on which this dependent variable is dependent. So the electric pulse, what the electric pulses are? This electric pulses in the artificial neuron, we represented this electric pulses, the electric pulses generated in the human brain, at the cell of human brain. This is a structure of artificial neuron, what is made by computer scientists. So this is artificial neuron consists of there are waves which represent electric pulses, represent or represented by weights. They are represented by weights in artificial neuron, and the independent variables are represented by these are called my inputs, and this is my output. And what we want is we want to approximate a function. We want to find a function that gives me the relationship between input and output. So what this function is basically, this function is represented in terms of weights. First thing, what we are having is the weights. We are having certain weights associated here, and we are having two parts in this cell. In this cell, we are having two parts. First part is the weighted sum. This I say is the weighted sum. What we do is we used to find weighted sum here. So Sj is nothing but it's a summation of all my inputs. I goes from 0 to n. W of I, W of Ji, W of Ji into X of I. So X is nothing but is my input, and weight is my initially we used to use random weight. Initially we used to, these are the random values. Weights are nothing but is the random values generated between 0 and 1. So weights are nothing but is the random values generated between 0 and 1. So what we used to do first in this particular cell, in this particular neuron cell, what we are doing is we are finding a weighted sum. As I said, in case of human brain, where my inputs are combined with the electric pulses, and then we'll find the output. So similarly, we are doing here for the combination, what we are doing is we are finding the weighted sum. On this weighted sum, then we used to apply a function. This f is called my activation function. Because if I find only the weighted sum, this weighted sum is not going to give me a non-linear output. Whereas everything in this world is non-linear. Because we want to represent the real world. So for representation of real world, basically we have to find a non-linear relationship. This, if we are finding just the weighted sum, this just weighted sum is not going to be this. This output is linear in nature, but to make it non-linear, we are applying different activation functions. Sorry, this is not activation value, this is activation functions. So we used to apply different activation functions. Then I'll have Yj I represent as my output. This is my predicted output. And predicted output is represented by y hat. So if I apply a activation function on this weighted sum, this will give me the output of my neuron. This is the output of this particular neuron. I used to write with y hat. So this is y hat is nothing but is the predicted output. Is the predicted output of my neuron. So this is processing at one particular neuron. If I add such kind of neurons, so multiple such kind of neurons in different layers, that makes my neural network. So this single layer and multi-layer perceptron is nothing but is a neural network. Is a neural network. So at the very beginning of my research, first we find out the single layer neural network. In single layer neural network, we are having just the input and output, and there is no processing done at the input layer. So this input layer, there is no processing done at input layer. That is why I say this this is as single layer neuron, because we have the weighted sum and the activation function will be calculated only at the output neuron. So these neurons, the output neurons, are having the weighted sum and the activation function. This is weighted sum. and representing there, and the activation function. These are the weighted sum and activation function. And here we are just copying the input. This is x1, x2, and up to xn. This layer is just passing the input to the next layer, and then we are having weights, some weights here. So this is why weight W11, this is W12, this is W13, and likewise we are having W21, W22, W23, and likewise the other weights we are having. So this is called my single layer. This one is my single layer. Why this is single layer? Because there is a processing possible at one layer. So this is my single layer neural network. And if I involve one or more than one hidden layer, then we say it's a multi-layer perceptron or multi-layer neural network. So multi-layer perceptron we used to write with MLP. So if we have a hidden layer in between input and output layer, then we say it is a multi-layer perceptron neural network. So this is the architecture of my multi-layer perceptron neural network. We have two processing units, processing layers, where we calculate the weighted sum and the activation function. So weighted sum and activation function will be calculated at hidden layer or at output layer. There's no processing done at the input layer. Input layer is just passing the input to my next layer. So we are having weights between this and weights between this. And what is the size of my weight matrix is, there is 3 neurons at the previous layer and 3 neurons at next layer. So we are having the weight matrix is of size 3 cross 3. Wij we are having is of size 3 cross 3. Here we are having weight matrix of size 3 cross 2, because sorry, this is W I J I. We don't write IJ, we write JI. It is 3 cross 2. If I have written IJ here, this please make it JI. We used to say JI. This is the index of my next layer. The jth is the index of my next layer, and ith is the index of neuron of previous layer. So we used to write j and I. So sorry, this will be 2 cross 3. This will be 2 cross 3 because we are having index of next layer, then index of the previous layer. So we require two weight matrix. One is of size 3 cross 3, another one is of size 2 cross 3 to get the output of this particular neural net. So now coming to the activation functions. What kind of activation functions we use? Weighted sum is very clear. We start with the random weights and we multiply with the inputs and we'll find the weighted sum. So after getting the weighted sum, then we used to, I'm saying, we want to convert my output to the non-linear form. So convert them into non-linear form. Either we can use a sigmoid activation function. Sigmoid activation function is a S-shaped function, and the range of this activation function is between 0 to 1. So whatever the output you are getting, it will be converted between 0 to 1. And we can have the linear weighted sum it can be negative or it can be positive. That we can have a tan H activation function if I want to convert my output between -1 to +1. Rather than 0 to 1, sigmoid converts my output between 0 to 1, whereas the tan H converts my output between -1 to +1. So if we convert the output -1 to +1, this gives me this gives me another function that is called tangents. Then next we are using the most popularly used the activation function, that is ReLU. What ReLU does is ReLU converts all the negative value, it makes 0, and all positive value it keeps as it is. So the ReLU activation function is basically it's a maximum of 0 or x. 0 is if you are having weighted sum as negative, it makes 0. And if the weighted sum is positive, then it will be kept as it is. Then there is a problem in ReLU because it is making everything negative as 0. So we are having a problem of vanishing gradient because all negative outputs become 0. So 0 gives me just the dark image, just the black image. So rather than making all negative values as 0, if we multiply this with a small amount, that is zero point 0.01. So if we multiply this with 0.01, then we'll be having another activation function that is called my leaky ReLU. So leaky ReLU means all negative ones we are converting, we are multiplying with a small value that is 0.1, and all positive one will be kept as it is. So this solves the problem of vanishing gradient. Then we are having max out and ReLU. They are also to overcome the problem of my vanishing gradient. Okay. So this is the architecture of my deep neural network. In deep neural network, there are multiple hidden layers involved. At least, if we have more than one hidden layer involved, then we say it's a deep neural network. Otherwise, it is called multi-layer perceptron. If there is only one single uh, hidden layer, so if we have single hidden layer, then we say such kind of neural network as multi-layer perceptron. It is multi-layer perceptron. Wrong. Or if there is more than one hidden layer, if more than one hidden layer involved, if more than one hidden layers involved, then we call NN as deep neural network. That is DNN. Deep neural network is nothing but is DNN. We represent with DN. So there are one input, one output, and there are multiple hidden layers. So in this one, we are having three hidden layers. So if we are having multiple hidden layers, adding different hidden layers, as many hidden layers you involve, that much your output will be refined. As I shown you, the output at the first layer you'll be getting the abstract details. At next layer you'll be getting a better detail. Next layer you'll be getting even more finer details, and likewise if you increase the number of hidden layers, your output will be refined according to this. But there is a debate that how many layers we can go for it. We cannot go for infinite number of hidden layers. So that's again a research problem. So here is the output of my early layers, middle layer, and the final layer. Then we have next form of neural network that is called my convolution neural network. In case of convolution neural network, we are rather than this network is capable of finding features of the image. So how it finds the feature of the image? The features of the image, it is found by the convolution operation. Convolution is the operation that is defined in the signal processing or image processing. Uh, with this convolution operations, you can get the features of the image. So the difference between the deep learned neural network and the convolution neural network, this is as abbreviation, it is called CNN. So this CNN is the very powerful tools. They are capable of get the features as well as classification. Whereas my DNN is the deep neural networks, They are doing just the classification. We need to provide features. We need to provide appropriate features to the network, to the input neurons. You need to, but in this convolution neural network, you can submit your raw data. So in from your raw data, it will first find the features, and after finding out the features, it will do the classification at this last layer, that is my fully connected layers. And because there is a convolution layer involved, we used to take at least 2, 3 convolution layer. Then we are having several fully connected layer. So this is example of my deep neural network. Deep neural network is nothing but if it is having more than uh, one hidden layer, we are having one input and one output, and after that if there are different layers involved, so in case of CNN at least 2, 3 convolution layers we are having, and there are certain fully connected layers involved. So this is a deep architecture, we say it's a deep learning architecture. So here I'm showing processing of a neural network, how my neural networks works. So let's imagine you have a picture, just a 4 pixel picture, in which we are representing the shades of gray with different values. So generally, if we go for a black and white image, so black is represented by 0 and white is represented by 1, and everything between black and white we are having certain numbers. That number is a some decimal numbers. So let's see, the brightness of my image is represented by, I'm representing black as -1 and white as +1, and everything between the different shades of gray, it is represented by different values between -1 to +1. So now, if I take this image, I have taken an image of 4 pixels. So the first pixel represented by zero point 0.5, next pixel is represented by 0, third pixel is represented by minus 0.75, and the fourth pixel is represented by plus 75. So, and if I see the location of these pixels, so this one is my top left corner. I'll say this is top left, this is top right. This I say is the top right. This I say is the bottom, bottom right. And this I say is the bottom left. So this is my arrangement of my pixels. So now what we want in case of neural network, first we want the weighted sum. The first step is step 1 in the neural network is we want weighted sum. So weighted sum is assuming if my all weights are 1 1. So if I have all weights as 1 1, my weighted sum is the summation of all the pixel values. It's nothing but is the summation of all pixel values. So that comes out as zero point 0.5. If I assign certain weights, like I'll assign minus zero point 0.2 to this neuron and 0 to this particular, sorry, not neuron, the interconnection. Minus zero point 0.2 to this interconnection, 0 to this interconnection, zero point 0.8 to this interconnection, and minus zero point 0.5 to this particular interconnection. So my weighted sum is input into the weight. If I add, this will give me the weighted sum. So this is my first step of neural network. I get the weighted sum. After getting the weighted sum, I need to apply certain activation function. So on this weighted sum, I'll apply a sigmoid activation function. This S-shaped function is nothing but is the sigmoid activation function. How sigmoid works is, sigmoid, I told you, this gives me the output between this is not sigma, this is a tan h function that gives output between -1 to +1. So if my curve keep giving me the output between -1 to +1. So whatever is my output, this represent my y, this represent my x. So if I'm having anything negative, whatever, how much high value you are getting for x, how much will be the value of x? This is my weighted sum. X is nothing but x here is the weighted sum. What we are having, x is the weighted sum. So whatever is my weighted sum, uh, this will be converted to, if it is negative, it will be converted to -1. And if it is positive, if anything positive comes as my weighted sum, this will be converted to plus. So this activation function gives me output between -1 to the +1. So, and if my output is my zero point 0.5 and 0.5, this will the input in, if the linear sum is 0.5, the output remains 0.5. There's no change in the output. And if I'm having anything greater than 1, this will be converted to +1. Anything greater than -1, this will be converted to -1. So now I want to find the weighted sum. So for finding out weighted sum, all the weights which are having um, magnitude as 0 are removed. There's no line shows for the weighted sum as 0. There is a white line shows for the positive weights. For the negative weights, we are showing the black lines. That is dark and light black. So now, after finding out, so like the white represent the positive weights, black represent the negative weights, and 0 represent the zero missing weight. Okay. So now these are my images. These are my initial inputs. I have the top left, then top right, then we are having bottom right and the bottom left. So this neuron, if I see this neuron, this is combination of this input and this input. This input is my top left and this is my bottom left. So top left and bottom left, and my weights are positive. Both my weights are positive because they are shown with the white lines. So the combination of these two will give me uh, two white pixels at the left. Same at this neuron, what we are having is, this is a combination of, this is a weighted sum. This is a combination of the top right and we are having the bottom right. Top right and bottom right. So this gives me top right and bottom right as white after, and because my both of my weights are positive. In this one, at the third neuron, what we are having is one weight is positive and one weight is negative. So the positive one, the input at positive one, this is the top left. Top left will come as it is because this is my positive weight. And this one is negative weight, so my input will reverse. The bottom left will reverse, so this will become black. Similarly, at this last neuron, what we are having is, we are having one weight as positive, one weight as negative. And from this, I'm getting input as, my input is, this is the top right one. And because it is multiplied with the positive weight, this will be coming as it is. This is a white pixel. And we are having a negative input with this. So this will give me a black pixel. So likewise, I'll do at every layer. So I'll repeat for the next layer. So you can see the black ones are the negative one and the white ones are the positive one. So if I apply the same operation, I'll get these outputs. So what I'm doing at this pixel, at sorry, not this pixel, at this neuron, I'm combining two images. This one is where we are having two left pixels are white, and at this one I'm having two right pixels are white. So if I combine the output of these two and my both of my weights are positive, I'll get a solid area, that is a solid white area. If I combine the output of these two with a negative weight, this one is a negative weight, so left two pixels will become black and the right two will come as white. Same if I combine the input of this one and this one. So this gives me output as same because this is a positive weight and this is a negative weight. So my output will be reverse. So the first one becomes black, second one becomes white. Similarly, if I do for the last one, in this last one, we are having both the weights are negative. So both of my outputs are inversed. So I'll get this, I would say it's a horizontal line. So if you see, this is a solid, this is a vertical line, this is a horizontal line, and this one is a diagonal. Now coming to the next layer, at last layer I'm applying ReLU activation function. You see the shape, this one, these one are the sigmoids and these ones are the ReLU activation function. Because in case of ReLU, what we want, all negatives become 0 and all positive becomes remains as it is. So ReLU is all positive remains as it is and all negatives will become 0 in ReLU activation function. So if I apply the ReLU activation function, so I have this is a perfect solid and multiplied with the negative output. So this gives me 0. This black is 0. It's nothing but 0. So if I'm again applying the ReLU activation function, the positive remains as it is, the black one becomes 0. The positive remains as it is, the black one becomes 0. So these are all my output. And if I combine these outputs, the first pixel at the first neuron, sorry, at the first output neuron, I'm getting a solid area. At second output neuron, I'm getting a vertical line. At third neuron, I'm getting a diagonal, and the fourth neuron, I'm getting a horizontal line. You can see the outputs. This is a solid area. This one is a vertical line. This one is a diagonal, and this one is a horizontal line. So let's say my input is a horizontal line. Now I want to match with my input. My input is a horizontal line. So this is matching with my input. So this neuron is activated. I will say this neuron is activated. So my output is for a horizontal line, I'm getting 1. And for rest everything, I'm getting 0, 0, 0. I'm getting 0, 0, 0. All outputs are my 0, 0, 0. And for vertical line, I'm having as 1. So this completes my forward phase. This is a processing of different neurons. This is how my neural network works. So there's a next part that is on learning of neural network. This is how my neurons, this is just an introduction of neurons, neural network, how different neurons are connected to each other and how they are working parallelly. And I would say this is my forward phase. I'm going from input neuron to the output neuron and how I'm calculating the output of different neurons. This is weighted sum and the activation function. So that's all about this video. In next video, I'll be having the part 2 of this neural network because neural network is such a huge topic. It cannot be covered in one particular video. So the next part of this will cover the learning of neural network, how the neural networks learn. Thank you very much. If you like my videos, please hit the like button. And if you have any queries, please you can write in comment box. Or if you don't have any queries, if you like my videos, please share to your friends. Thank you very much.